Well, good morning, good afternoon, or good evening, everyone, depending on your location and the time that you are listening to this webinar. Welcome to the Standard Imaging webinar on the QA BeamChecker Plus. This device is for daily LINAC QA, and I'd love to show you today how fast, simple, and reliable that it can be for that use. My name is Dan Schmidt. I'm the marketing director here at Standard Imaging, and I am also the product manager for this device. So as we get started today, I would first of all just like to take this opportunity to salute all of the healthcare workers on the front lines of the COVID-19 pandemic. Their amazing dedication and sacrifice are certainly an example for all of us. Amidst all this change, we know that cancer doesn't stop and that patient health issues are going to continue to be at the forefront. Speaking to the medical physicists, we know that your time is extremely valuable, so we hope that you will partner with Standard Imaging to assist you with efficient and precise solutions for daily, monthly, and annual QA. And speaking of that assistance, we also hope that you can join us at the 2020 joint AAPM comp meeting this year. It's coming up very soon on July 12 through 16, the normal hours. It is going to be a new experience for all of us, being a virtual meeting, but all of the smiling faces above here are looking forward to chatting with you and video conferencing and hoping to solve all of your QA needs. So please feel free to visit us at the exhibitor section of the AAPM meeting that's coming up on July 12th. All right, so just a few quick housekeeping items here. Did want to indicate, as you perhaps heard, that today's webinar is being recorded for future review, and you will get a link to that recording coming up here probably in a day or so. There's a question box that should show up down on your file menu under the webinar that you can enter questions at any time, and we will attempt to address as many of those as we can at the end of the presentation. You are in the meantime in mute mode. You're not able to speak, but again, we'll try to answer any questions that you've got. So Standard Imaging, based in Middleton, Wisconsin, close to Madison. We're founded in 1989, so we've been in business over 30 years, and we do manufacture a full suite of QA products for radiation therapy. Well, let's talk a little bit about your daily LINAC QA objectives. You certainly want to verify that your LINAC beam has not changed from a known value, that you picked a time to begin a baseline, and you want to know, is the beam output, the flatness, or the symmetry consistent for all of my energies from that time forward. You also might want to verify that the constancy of your wedge beams remains the same over that time, whether those be a physical wedge or an electronic dynamic wedge. You could also verify the consistency of things like your MLCs. Are they operating correctly? And is your output remaining correct for gantry rotation? I have a question here that I have no audio. Let's see, before I go on, I want to be sure that others can hear my audio. I know that Ashley is online. Ashley, can you hear me? Ashley indicates she can hear me. So Frederick, I'm not sure. Thank you for the feedback, everyone. Frederick, I'm not sure what is the issue on your audio, but we can certainly follow up if there's a setting and you need to hear the recording later. So let me continue then, if I might. Other objectives, you might like to verify that the output of your LINAC is consistent with gantry rotation, that it does not change as the gantry is rotated to different angles. And you certainly would like to get some convenient trending and reporting of the data that you're gathering to make that easy. So this is a phrase that I guess I learned from my piano teacher a long time ago, saying, here, play this piece as fast as possible, but not faster. And I think that kind of gets to the philosophy that you're trying to balance time and quality here. You want to do a thorough job of your morning QA, but you obviously can't check every single setting on the device in the morning to verify that it works. So it's that balance of doing it efficiently and effectively, and we believe that the QA BeamChecker can definitely help you do that. So let's go a little bit deeper into what the AAPM Task Group 142 for daily QA recommends, and I believe that these requirements are similar for other countries as well. You're certainly going to want to follow TG 142 to verify that your photon and your electron output constancy are remaining stable, that your lasers are localized, that they haven't been bumped during use from the previous day, so that you line your patients up incorrectly. Then you want to show that the ODI is indicating the correct collimator size when it's set up at your ISO center, that the collimator size is correct. And then you may also want to run a morning checkout on perhaps one wedge angle and verify that that has remained constant as well. I do want to point out that the data from the QA BeamChecker can be pulled into QA Pilot, which is our integrated software platform that allows you to centralize and manage all of that machine QA data and trend it and analyze it in everything in one spot. So if you need more information about that, certainly feel free to reach us at the sales addresses and or our website that you'll see at the end here. All right, so let's talk about the BeamChecker Plus itself, some of the basic specifications of the device. We've got 8 parallel plate ionization chambers built into the device, and of those 5 are actually measuring the flatness, symmetry, and constancy, and 3 others are being used to analyze the energy of the device, which is the key, as we'll see later, for the simple operation. The material is water equivalent, so there's 1.5 centimeters of material on the electron side and 3.5 centimeters on the photon side. And that allows you to measure very easily and simply on the photons cobalt energies all the way up to 25 MV, and on the electron side from 6 to 25 MeV. You are able to track 9 individual radiation treatment machines with this device. We call them rooms on the front. It would display when you turn the device on RM1, RM2, and you just simply select the room that you've designed to design the plans for. We find, again, going back to the time and quality, that most people, in order to efficiently do their morning QA, they probably would use this on 2 machines at the most, 1 to 2 perhaps, but you certainly are able to do more than that. The device does hold 512 data points, so that there's never really any concern that you would need to run out of memory space, and there are indications that it's time to do that. And as we'll see later, you simply download the data every week, and there's no issues there. And then finally, you want to trend the results and generate reports with this device, and we've got some very unique software that I'll show you in just a little bit that helps make that an easy task. And then there is, as shown down here on the bottom, a power data cradle that comes with this device, which allows easy charging. So we'll look at later taking it off this cradle and using it in a wire-free manner. The battery power in this device will run it for up to 4 hours when it is fully on. When it is just setting off by itself in a quiescent mode where it's not operating and perhaps you forgot to set it back on the cradle, we've designed it very carefully so that it will live for about 3 months without any need to be charged. We do send it to you fully charged, and that is the idea, is that when you get it, it's not going to have a dead battery in it. So we don't find that people have any concerns with that at this point anymore as well. All right, so we believe with this device that the ease of use really is the key for simple operation. And there is this patented wire-free mode that essentially means you don't have to run as a therapist in the morning. You don't have to run any software to do the testing in the morning. There's minimal preparation, and there's a quick pass-fail indication for each beam parameter. And typically every morning you can sail through your morning QA without any issues, and it saves lots of time. There is the option if you want to run this in a real-time mode, which is what we would call it when you connect it to the PC. That is also available, and you can run it through the software if you want, but you certainly don't have to. And I would say that perhaps 3/4 of our users perhaps run it in this wire-free mode just because of the ease of use. The device features automatic energy detection, and that's those extra 3 channels that have a variety of filters in there which automatically key the energy to the baseline flatness, symmetry, and constancy that you have put into the device in the initial setup of it. And that's how the device determines which baseline values to check and tells you whether it's good or bad. Now that's great because it means you can deliver your energies in any order, and it helps reduce any errors that you might have if you're doing them in a different order in the morning. All right, so another unique feature is the integrated buildup. So the 3.5 centimeters on the photon side and the 1.5 centimeters on the electron side means that the majority of these, for the majority of the energies, these are being performed near or beyond Dmax, and that's giving you a very stable signal on that buildup curve, so that things are not changing. There's also some unique QA modes that allow you to deliver dynamic beams, and we'll show you that how these can be set up as well, so that for your rapid arc or VMAT delivery, you can actually treat the ionization chambers if you want to test in that fashion. You can do a tomotherapy tests as well with this device, and we have quite a few users that are doing this for their morning QA on a tomotherapy system, and you can do constancy checks for wedge beams as well. There is, of course, automatic temperature and pressure compensation that is built into the device, so you don't have to worry about that. And there is a real-time clock that puts a data stamp on all of the points that are collected by the device. And then finally, there is a physics mode, which if you want to do some research or just some simple testing, allows you to, in the PC, in the real-time wired mode, allows you to get that data in real time and to essentially see 5 ionization chambers acting in real time and collect data and download that later if you want to do future research or other work. So let's look a little bit at that initial configuration and how that baseline setup works when you first get the device. So you place it on the treatment table, and you can either connect it with a standard serial connection as shown on the left here, a standard serial cable, or through a Bluetooth connector that is available. Now, we use a serial cable here because you can run these long distances as opposed to USB cables, which have some issues with longer distances of signal degradation. You can run serial cables up to 300 feet, but you say, well, I don't have a serial port on my computer. We do provide you, along with the device, a serial to USB adapter along with the serial cable. So you can very easily run the serial cable into your vault from the control room, plug that into the system, and then on the computer end in your control room, you plug into that serial to USB adapter, and you just need a USB port on your computer to run that software. On the Bluetooth side, this Bluetooth transmitter plugs into the device, and it also then would plug into the other end of this serial cable that you would have in the treatment room. So that's how you'd make the initial setup, talking to the device through the software. And now you want to set up and baseline all of the energies that you're going to measure. So the software allows you to define the action levels as well, and I'll walk through kind of the parameters. So this is a screen grab of what you might see a couple screens through as you've set up the device. Here you see that you've defined that I'm going to shoot it with a 6 MV photon energy, gantry angle at 0, a 20 by 20 cm field size, 100 SSD, my dose of 100 at a dose rate about 400. The date and the timestamp is put in here automatically. And here's the action levels, which you can set independently for flatness, axial symmetry, transverse symmetry, and output or constancy. Action level 1 is a level where and it depends upon your institution and the policies that you have set. You can define what that percent off is. So if my signal is off, say by plus or minus, in this case, 3%, that tells me that if it's below that, I'm not going to alarm. I'm going to accept it as an acceptable reading and move on. If it's between 3% action level 1 and 5% action level 2, I'm going to get that initial alarm, and that's a level where I might be concerned that something is trending incorrectly, and I should probably have my physicist look at this, but it's not an indication that I need to, shut down treatments for that day. The action level 2 is that setting above which, yes, something has gone wrong and I need to call my physicist before I start treating that day. You'd require, this is the initials of someone who is doing that measurement, and you can also put in a description and modify that as well. So this is the initial setup that you would do for your device, and you can see there's 4 simple tabs on the bottom. This one for doing the baselines, a real-time operation down here if you were going to run it in the real-time mode, and then the data view, which we'll look at in a little bit to view the trending of your data, and finally this physics mode that I talked about as well. And you can see on the left side here, this device has actually been baselined in 6 different rooms, and I can pick those all as well through here, as well as in that wire-free mode on the face of the device. So I've gone through and I've defined the parameters of my beam, and now I simply deliver my normal LINAC beam I'm gonna wait for your screen to catch up here. There we go. So I would deliver the normal LINAC beam for every photon energy that I want to test in the morning on my normal beam. I then would place the device on the power data cradle, and I am ready for my next day's measurements. I'm ready to do my daily QA. And now at this point, here's what the morning procedure then would look like when the therapists come in to do the morning checkout. Simply remove the device from that power data cradle, and then they would place it onto the treatment couch and do an initial alignment. So looking at the white face of the device here, we've put an awful lot of thought and user interface work into making this simple and easy to do. So first of all, you set it on the couch, turn on your ODI and verify that the distance is 100 centimeters, whatever your ISO center is, and then turn on a 20 by 20 collimator field, your field light, and you can very easily then align to the outside edges of the field lines that are shown here for your 20 by 20 collimator size. They're very precise millimeter, sub-millimeter marks here, so you can identify if anything is off. And you notice that we've got an interrupted line as well, spots where there are white and black lines. And we found in the past this, through some effort, that this makes it very easy to do a quick and simple visual alignment of the field light. In addition, there are you would also have your lasers on, and there are laser line indicators on that face, as well as some along on the device here and here, to help you verify now that my lasers indeed are all correct. So with that one simple setup, you've checked out those two systems and verified that everything is working correctly. Then you would go back into the control console and put the patient camera, aim the patient camera there at the device. Since it is turned on, you will see that there's a green light on here and the device says it's ready to go. You know that you're on the photon side because this light is lit up and the display is correctly facing. When you flip it over on that electron side, as we've talked about, and you press the button to flip the mode, the ready inverts itself, and we'll see that in just a second. So it guides you so that you don't make any mistakes there. So again, no wires connected, all ready to run and do the beams. And then I deliver any beam for which I have previously put a baseline into the device, which is stored and saved in here, keyed to that energy score that those three ionization chambers determined when I shot that particular beam. So as an example, here we see once I've completed my irradiation for the day, the first one, it's identified that this is a 6x photon beam. And again, if all of the parameters that were previously stored during the baseline match those values within the action levels, within 10 seconds, I simply get RDY on the front screen again, and all of the values, the flatness, symmetry, and constancy, are stored as data on the device itself. And that with the RDY showing back up, the ready, I'm all set to go for my next energy. And I can just run through all the energies. So what happens if the beam is out of tolerance? So perhaps I've accidentally doubled up on my output. I delivered 200 monitor units instead of 100. Well, then I would get an error on the front of the panel of the device. So constancy would be CST, transverse symmetry, TSM, flatness, FLT, or axial symmetry, ASM. And if there are multiple ones of these, something goes seriously wrong or transverse symmetry is off, so is flatness, both of those will flash one after the other. This green light would then become a red light and it will beep and flash at you depending on, at higher levels, depending on whether that's an action level 1 or an action level 2. Just a very slow beep and flash for a 1 and a much faster, higher insistent flash and beep for level 2. You do need to go in when those errors occur if you're in the wire-free mode and press this reset to get it back to ready. All those values that have occurred during the error are stored on the system. In the wire-free, in the real-time mode, when you are running it through the actual software, if you want to choose to do that, you don't have to go back in. You reset that automatically from the software. Okay, and so I went through all of those items. So now I want to do my electrons. So I do need to walk back into the bunker and flip the unit over, which I'm doing anyway to put an electron cone in. So really all you're adding here is one additional alignment of the light field to the device. And I would press that mode button to flip it over to electrons. And as you can see here, the ready is now on the other side and it's been inverted so that I know I'm on the electron side. When I've taken all of my electron energies then, I simply place the device back into the cradle and it will charge it back up and be sure that it's all ready for the next day. So we do recommend then that you download your data perhaps once a week, and that is, I think, what the majority of folks are doing. Some perhaps do it every day. Some do it longer than that, but a week is probably a good time frame. When you run the software then the first time with data on the device, you'll see this red button. I'm sorry, it's a green button that says new data is available. And when you click to download it, it will give you a simple report of the data that it has accepted and it is pulled into the database. In order to then view that data, you choose whether you'd like to see photons or electrons and the energy that you want to see. and it will then display the data that it's got. And again, you can pick the dates and the end dates. You can look at it in the chart view, which is what we're doing here. You can also look at it as a table view, and you can, with these tools, zoom in and see specific areas. The green color in here indicates that all of this data from March 16 to April 18 was within the acceptable parameters. The yellow is indicating that region between action level 1 and action level 2, and the red is indicating that it's in action level 2. So the trending of this is very nice, that you can get a good look over long-term times and see is one or other of these parameters varying. And by clicking on the buttons down here in the bottom, you can turn any one of these color-coded matching ones on or off to see them more clearly. If you'd like to look at this data in a little more detail, you can always export it over here with this button as a .csv file and pull it up in Excel. And to your heart's content, look at all of the data, everything comes out of it. And you can then print your reports by clicking on this button. And what would some of the reports look like? You just simply pick the energy and the date range that you're looking for, and you can print that data out. This would be the table view in the back, or a report of the chart view in the front. You can, on the table view, choose to not chart a particular value. If, for instance, you did an error such as I described before, like you accidentally irradiated 200 monitor units instead of 100, and you know that wasn't a machine fault, you can simply go in there and click that and write in a comment saying, I made a minor boo-boo here, ignore this one, it's fine. You can also do that automatically in the real-time mode in the software when you're looking at it and accepting those values that come in the real-time mode. You can type a comment right in there that shows up on these reports. If you want a nice clean report because of that, then we do allow you to not chart it here, but you can't delete any of those energies. They always show up on the screen. You can just comment them out. And of course, there is a box for you to sign off on the device as well, or on the report, excuse me. And then in that PC mode, as I've been speaking of, you do get just a little bit more measurement information. So it would show you the exact, rather than just saying flatness is okay, symmetry is okay, you actually get a measured value of what that is, and in a comparison to what the baseline, the difference of the baseline, and then this visual indicator for yellow, green, or red, again, if you're, depending on which action level that you are in. So let's talk just a little bit about the dynamic beam QA portions of this. So you can do, for enhanced dynamic wedge, you can treat any of the beams as a separate any of the ionization chambers as a separate chamber that you could do a CT of the front of this device, and you can do a treatment plan and plan different treatments for any of those ionization chambers. So for your rapid arc or VMAT, all of those can be set up in the wire-free mode. There's a compatible, very simple way to set up those as a static or as a dynamic treatment. And there's some specific ones for the high-art system as well as the H series of the Radixact for Accuray that I'll show you in just a second. There is an optional gantry mount if indeed you want to slide this into the collimator and lock the head in and then do a measurements at different angles. You can do that. Provides a little bit more repeatability, perhaps, with exactly positioning the surface of your device at a constant distance away as well. The tomotherapy, then this is just a quick little bit more about how you would do on an Accuray tomotherapy system. There is a specific mode that would output the constancy of the device, an energy check, as well as a lateral profile constancy. Of course, the tomotherapy beam being a thin 5 cm to 1 cm wide, you just use the center 3. You do an initial leveling out at virtual isocenter with this optional leveling plate. Do all of your alignments there. There are fiducials, 2mm lead balls embedded on the sides and at the center. you'd run that into True ISO Center and do your daily imaging, do the matching up to the CT image and identify that that's working correctly, and then go ahead and treat the device. You could do both a static measurement in perhaps tomo direct mode in order to get these lateral profile energy and output constancies, or you can also do a dynamic mode and actually treat any of those 3 ionization chambers with a specific value. So in summary, I hope that I have convinced you that the QA BeamChecker Plus is a simple, fast, and reliable device for daily Linac QA, that the innovative wire-free mode will let you do this in a software-free operation, and we've seen therapists really love that it makes life easy and quick for them, not another thing that they have to worry about. The integrated buildup and the high quality design of this device provides some very stable readings. Standard Imaging as a company really is known for our high quality metrology, the measurements of very small signals. It's something that is a core technology of our company. And because of that, these devices we've had in one form or another, a QA BeamCheckers, I've been in the field since 2007, and there's over 1,000 of these out there. So a very good, solid, stable device and long lasting. That automatic energy detection allows you to prevent mistakes. You can shoot the beams in any order. That's an easy way to key to your measurements. And because of this robust system, we do offer a 2-year warranty on our device. I hope that the intuitive trending and reporting that I've shown you is in agreement. It's a very easy and simple way to see that data, and the ability to also do rotational and dynamic QA along with quick checks for tomotherapy, rapid arc, VMAT, or your dynamic wedge measurements is also very helpful. So that is all that I had planned. I thank you for your attention today. I will say that if you need more information, certainly feel free here to visit www.standardimaging.com. You'll see a little blue button on our website that says Find Your Account Rep. And if you click on that, it allows you to put in your country or state and will direct you to the email address of your account representative. You can also simply send an email to sales@standardimaging.com, and we will certainly get this to the right person. And then just a reminder to please join us at the virtual joint AAPM comp meeting coming up July 12 to 16. We would be very happy to chat with you via video or directly through that interface. So I will wait just a minute here and check out the question box and see if there are any specific questions. I do see one here right away that came in during the presentation, can this device be used for ortho voltage, 100 kV or 140 kV? Unfortunately, the buildup that's on that electron side is not going to allow ortho voltage signals to reach the ionization chambers. That's 1.5 centimeters of water equivalent buildup. Another question is, can I offer the BeamChecker for CyberKnife? It actually does work. Now, I don't have a lot of people using CyberKnife, so I typically don't go too deep into that. We could certainly have an additional discussion if you'd like to about that one. Feel free to reach out to me to talk about this. People are using it for daily constancy for their CyberKnife. We have a device called the cutting board, which essentially sits underneath the BeamChecker Plus and offers fiducials so that you can use the system, the localization system, to identify the position and space of the BeamChecker, and with the CyberKnife robot do a treatment. And the fact that you can set all of those individual levels, all of the individual channels at a different flatness, symmetry, and constancy at a different action level, you can use that to your advantage, and actually you just worry about the constancy and you deliver a beam to the center ionization chamber. and we can talk about some of the details. And there is a limit. The ionization chamber diameter, it's a 0.6 cc chamber, just like you'd find with a standard farmer ionization chamber of a 1.4 centimeters. So the very smaller beams may be an issue, but I can certainly give you some data there as well. I don't see a lot of other questions. Frederick, I hope that you got yourself connected. I will reach out and be sure. It looks like it was just you that was unable to hear the audio, but we'll follow up for sure. I don't see any other questions at this point. So again, I thank everyone for their time. And oh, very good. You got it through the phone. Excellent. All right. I thank you very much for your time, and I hope that perhaps we can chat at some point during AAPM. I hope that you all have a good day. This ends our recording.